Yeah. I gotta say though, I thought it was a good movie. I do prefer Infinity War over it. Uh, I just thought Infinity War was way better than Endgame. Uh, I'm kind of curious to see where they're going to go from here. I know the movies that are being released. It's going to be part of Phase 4, but like the big story arc, I've read different articles that kind of hint at Secret Wars. If you know what that is, I don't know if they're going to do that. I mean, I think it would be a great opportunity now that they're kind of done with the Infinity Stones, or at least I hope they are. Maybe move on and start bringing in some characters now that Disney owns everything. We could probably say the word mutant now legally. Not have to. What do we call them in the MCU? Enhanced or something like that? Yeah. We bring in Fantastic Four, Doctor Doom. That would be cool. That would be really cool. Because the Fantastic Four movie they made previously was pretty bad. I don't know. Yeah, I wasn't too impressed with it. Anyways, I'm sure, you guys haven't been waiting all this time to hear about comic books. You want to talk about math. Yay! What's up? We are on review 3. Review 3. In fact, how did things go yesterday? That was good? Okay. All right. Well, we have less than 2 weeks to go ahead and wrap everything up. In fact, 2 weeks from yesterday is when you're going to go ahead and take your first exam. We will be ready for it. Things are going to, unfortunately, be slowed down for us next week, the last week of review, because the STAR testing begins on Tuesday with Algebra 1. And the schedule is going to be changing. We'll go through 1 through 4 one day and 5 through 8 the next. So I was already looking ahead to figure out the best time to do this, because one of the other things I want to do after we finish up all these reviews is actually run you through last year's test. Actually give you the 90 minutes to go ahead and run through these. And it looks like next week, they haven't released everything yet, but it looks like I'm administering a test on Tuesday and Thursday. So Wednesday, I know it's going to be a late start day, but would people be willing to come in about 8, and then we could go ahead and do those? That would at least give you a little more time to look over it before. Dang it. Well, the only time for me after school would depend on if my wife is working that evening or not, because then I would have to pick up the kids. So I don't know, and I don't want to do it too late, because if there's questions, I want you guys to be able to ask me about them. Let me see what I can do about that. Okay, but I do have last year's released exam, papers 1 and 2. I think really the only final grade I need to do is maybe another exam grade. I'll probably go ahead. I was actually thinking about taking the last review and probably just making it a test. Well, I mean, for district policy, we need 2 exam grades of 6 weeks. I mean, or I could just make something up if you guys want me to. I mean, you haven't seen review 6 yet, so I don't think it's horrible. Hey. Oh yeah, we're gonna get to it. Hopefully, we're gonna finish up the majority of review 3 today, and at least start review 4 tomorrow. Okay. Yes. If you want, usually that's up to the student's decision. The way, unfortunately, we have policy here at LHS, you can't take the final early unless you have written permission from your principal, and it's really rare nowadays that they actually give that out. Um, what I always do, if for some reason a student is not going to be there the day of the final, I take the average of the 4th, 5th, and 6th week's grades, and I just put that in as your final test grade. And then that helps to determine what your semester average is. Or if you're not big on that idea, you could go ahead and come in at some point after that. I could just write you as incomplete. Okay. But a lot of students just opt to go ahead and take the average of the 3 6 weeks. That way they don't have to take the final. They don't have to worry about it. I mean, who wouldn't, right? One of the last math tests of the year. You're like, yeah, exactly. Okay. All right. Well, let's see here. I believe we finished up with half of number one. We did the chi-squared portion of it, and we were just on the correlation coefficient. I think, because yes, one of the last things I did was to go ahead and plot all those points on, was it Thursday or Friday? Friday. Friday, right? Okay. Friday before we took off. Okay, so let's see what we have here. We have this information comparing height and weight. A, plot this information on the scatter graph. Okay, done. B, calculate the mean height. C, calculate the mean weight. Now, I went ahead right before the bell rang. I went into the calculator and I went ahead and input all the data. So it looks like the mean height, I have 166.1. What are we doing in centimeters? Yes. So 166.1 centimeters. 166.1 centimeters. And then it wants the mean weight. So let's see here. Mean weight, I'm looking at 74.9, and we're measuring this in kilograms. 74.9, okay. So 74.9 kilograms. Okay, and then part D, it's given that S sub xy, remember that is the what? Starts with a C. The covariance, okay, is 44.31. It says, by first calculating the standard deviation of the heights, correct to 2 decimal places, show that the gradient of the line of regression of y on x is 0.276. So there's the slope. So I did give you this hint last week when you guys were looking at it on your own. If you take the covariance and divide it by the squared standard deviation for the height, it should come out to that. So let's go ahead and see what the standard deviation of the x's is. Oh, and it's right there. So it says correct to 2 decimal places, so I would say 12.68. Okay, 12.68. 12.68. So let's go ahead and plug this into what we have. I'm going to have 44.31. Let me go home. Calculate. Control divide. 44.31 over, I completely blanked on what that number is, 12.68. 12.68 squared. Okay. And there we go. There's that 0.276 that we were talking about. There is also another version of it. Another way to go ahead and calculate the slope if you don't have the covariance. Okay. You could go ahead and take R times the standard deviation of the y's divided by the standard deviation of the x's. Okay, that should also work to go ahead and get you the slope. Did anybody happen to go back into the notes for correlation and find where that was mentioned very briefly? No? Okay, if you wanted to, it's there. Now, I just realized I kind of skipped past where I put everything in the calculator. Did anybody want me to run through the keystrokes on how to go ahead and get that stuff again? Okay, so let me go back over here. And I've already got it pulled up, so I won't go ahead and push enter when I'm done. But let's see, I'm going to go to current. So, of course, you want to go ahead and put in all of your data. Okay. And then, of course, you want to find an empty cell. So let's say I hadn't already pulled up all this information. Okay. How do I get there? Menu. Statistics. Stat calculations. Is this 1 or 2? This is 2 variable. We are comparing 2 quantities. You only want to choose 1 variable if it's a frequency. Yes. Okay. Even though it might, have 2 columns, remember the frequency list is only 1 quantity. So I would choose that. And then remember you want to make these changes here. You'd go ahead and plug in X for that one, Y for that one. Go ahead and click OK. And like I said, I'm not going to click OK though because it's already pulled up. But that would provide me all this information right here. Okay. Questions? Okay. So let's see, what's next? Calculate the equation of the line of best fit. Okay, so we've done this by hand, but let's just go ahead and do this on the calculator. So I know I'm going to go home. I got the data in. Now remember, I want to go ahead and choose this right here. Okay. This is the one time where none of our calculator screens are going to look the same. It just kind of throws the points on the screen. So I need to go ahead and tell it, the horizontal and the vertical. Okay. I like to choose, you can choose these right here if you want. I always like tab. Okay, because it goes ahead and brings up the name of the headings for the columns you plugged in. X is always first, and then tab. Let's go ahead and plug in Y, and there we go. And then you see there's that one outlier, just like we have on our graph. Okay. All right. If we go ahead and take a look at that. Okay. So how do I figure out what the equation is? Menu, analyze, regression, and then show linear, mx plus b. Okay, so let's say if we go ahead, let's do it to 3 sig figs. How about point what? Okay, so 0.276x. Let's see if I can do this with the mouse here. So y equals 0.276x. And then what was my y-intercept? What would that be? Okay. So we could go ahead and say 30.1. Do you guys agree? Oh, I rounded up. Yeah. 29.1. There we go. Was that plus or minus? Plus 29.1. Plus 29.1. Okay. Yeah, but I need to work on my mouse writing. D3, draw the line of best fit on your graph. Okay. So I'm going to come on over here if I can get this going. Okay, so the y-intercept was 20. Quit showing Batman. Not that Batman's not cool. Okay. 29.1. Okay. So let's say about 29.1, so really close over here. In fact, let me go ahead and do this. 29.1. And where would you like me to put this? Because the slope is 0.276. So further down, further up, where would you think? Right about here? That's where you want me to? A lot of people are shaking their heads, yes? That's a good point. What was that grand mean? Okay, so 166 and then 74.9. That's perfect. So let's say maybe right about here. Okay. Perfect, 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 perfect. So just below 30 and right there. There we go. So it may be a hair off, but that's okay. All right, perfect. Now use your line to estimate the weight of a student of height 190 centimeters. Okay. So my height here is the horizontal. So it said 100 and what? 190. So if I go ahead, start here at 190. If I were to go straight, pretend that's a straight line. Again, I'm using the mouse. No, I'm at 190. Because here's 180 and then here's 200. Okay. And then let's see if I can go straight across. Okay. What do you guys think? Looks like I would have 75 right here, so maybe about 77, 78. Okay, somewhere about that. Okay. So let's estimate 78. I keep hitting the wrong button. Okay, so let's say about 78 kilograms. The height of a student of weight, 72 kilograms. There should be. Now, if they're going to have you use your equation from the calculator using the technology, there probably won't be as much, but definitely here, if you're using the line of best fit by graphing it, there should be a set leeway. Okay, something for them to work with. Okay, and then we're wanting to go 72 kilograms. So let me choose another one here. Let's go purple. So 72, maybe right about here. Go straight across. Let's see how straight I can keep it. Hit the graph. Then I'm going to come straight down. If it was a straight line, it would probably be right about here. Okay. So if you were to go straight down, I mean, I curved it a little bit. Caitlin? Sure. That's right there. So what would you say? 160, 66? Yeah. Maybe. 170 is in the middle. Looks like the upper part. Yeah. Okay. I probably would have said 165, so that's perfect. Okay. Good. So 166, let's say. Okay, so this right here was kilograms, and this was centimeters. Okay. And last one, it's decided to remove the data for student number 10 from all calculations. Explain briefly what effect this will have on the line at best fit. Well, let's see. If I were to go ahead and do this, if I removed this one right here, what are some possible answers that you think you might put down? Like in terms of the slope. Do you think the slope would be more or less steep? Okay. Well, let's see. If I were to remove that point right here, I'm probably thinking that it might look something like that. Okay. So what happened to the slope? So it did get steeper. Okay. You maybe even go ahead and talk about the fact that how did the y-intercept change? It would now be what? It would now be negative. Okay. So I'm not sure exactly what they're looking for on that one. I would probably just describe it in the basics. Probably the gradient would be the best one. Okay. Questions about that? Because if this is 0, then the line would continue down here. I'm just talking about the line itself, because this represents 0, 0. Well, realistically, it wouldn't, but algebraically, it would be negative because it doesn't cross the y-axis until it gets down here. Does that make sense? In the real world, we'd have to go ahead and restrict ourselves to the first quadrant because, you know, the weight's not going to be negative, the height's not going to be negative, but algebraically, the linear model I'm using would go forever. So it would go ahead and cross at certain places. Okay, Haley, how's that? Okay, okay, all right. Okay, moving on to another type of problem. Looks like we have a truth table, but we're also bringing in a couple of vocabulary words right here. The following truth table contains 2 entries which are incorrect, one in column 3 and one in column 4. Okay, so let's take a look at these. Okay, column 3 and column 4. Okay, circle the 2 incorrect entries. So let's do this by row. You think in column 3 it's row 1, 2, 3, or 4? 2? So we're thinking this one right here? Okay, it's 4. So we're thinking this one right here? Okay. Well, what is this right here? Is that the intersection or the union? That's the intersection. Okay, that's the intersection. Remember, the capital upside down V has the same effect as the capital upside down U. It is the intersection. The only way to get a true out of that is if both propositions are true. So here, false, false, that one should be a false. So that false in the second row is correct. Okay. And then what's that sideways L mean? Not. Okay, that's the negation. And remember, you might see that as the tilde symbol, just like a little curvy line. So which one am I looking at here? Okay, row 4 again. Because if P is false here in column 1, it should be... I did. There you go. It should be true right there. There we go. Okay. And then fill in the 2 missing columns in column 5. Or 2 missing rows, I should say. Values. Okay, so this one is the what? That's the union, but is it inclusive or exclusive? That's inclusive. Inclusive does not have the bar below it. What was the difference between inclusive and exclusive? Okay, so one or the other or both is inclusive, one or the other, but not both is the exclusive. So this one here, we're trying to compare P and Q. So one or the other or both, true. One or the other, so this would be a true, okay, one or the other or both, This one would be a false. Okay. And then it wants to go ahead and take the intersection of the third column and the fifth column, or actually no, the intersection of not P and not Q, which is not shown. Does anybody want me to go ahead and finish that up, or are we okay just accepting that the last one is all falses? All good with that? Okay. So which one of the following words would you use to describe the statement represented by the values in the last column? If they're all falses, it's a contradiction. If it's all truths, it's a tautology. Okay. Oh, let's go over while they're all false. So I've already got P or Q, so this is column 5, but we need to go ahead and add another column, not Q, in order to get the intersection of this. So let's say not Q, so that's just going to be false, true, false, true. False, true, false, true. Okay, so now what we want, let me go ahead and do this one up here. Not P and not Q. Okay, so I'm going to go ahead and compare not P and not Q. So not P and not Q. These two right here. So what would it be if I went down the line? False, 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 true. Okay, false, 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 true. Okay, because remember, as you go through the intersection, both have to be true in order for the outcome to be true. So here we have a true, false, so it's false, 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 another false, false, but here we have a false, false. Wait a minute. Did I mess up on this one? Was I looking at the wrong one? Oh, I looked at the wrong one there. Yeah, true, false. That would be true, true, that's a true. Okay, there we go. And now what we want to go ahead and do is take the intersection of column 5 and this one right here. Like, let's call this column 8 because this one was the 7th one. Okay. So the intersection of 5 and that one. So it'd be true, false, which is a false. True, false, false. True, false, false. False, true is a false. There you go. So this is a contradiction. And a tautology is if they're all true. Okay. Now remember the implication. Let me go ahead and erase this real fast because I want to go ahead and see if you guys remember what the others mean. Okay. If you have P implies Q, okay, because it's important to remember what the others are. What does the converse mean? I'm sorry? No, they're either both going to be negative or both positive. So the converse would be just to flip it. That means P implies Q. Now what would the inverse be? That's simply when you negate them. So not P implies not Q. And what does the contrapositive mean? Switch them and negate them. So that would be not Q implies not P. Yeah. Helps. Did I say? I think I said QP, and then yeah. There you go. Yeah, the converse is simply to switch them. The inverse is to negate them. The contrapositive is to negate and switch. There we go. Okay. Cool. Any questions? All right. What's next? Looks like number 3 is a piecewise function. A function f of x is defined as, we have 2x if x is between 0 and 3, and 9 minus x if x is greater than or equal to 3. So these right here are what we refer to as subdomains, when it says x belongs to the reals. Complete the table below. Okay. So when x is 0, the function is 0. When x is 1, the function is 2. So when x is 2, where do I plug in? There you go. Now, how would I know I plug it into 2x and not 9 minus x? There you go. Look for that subdomain that contains the value you're looking for. See, 2 belongs to that one. So 2 times 2 will give me 4. Okay. What about 3? That would be 6. It still belongs from 0 to 3 because the 3 is included. Now, here's the thing. It's also included on this one, right? So if I do plug it in, doesn't it give me the same output? So either way, it's going to be 6.
Yes, it is. Sorry.
Okay. No. All right. Now, starting with 4, that falls into the subdomain greater than or equal to 3. So I've got to subtract that from 9. So x equals 4 would give me 5. 5 would give me 4. And then 6 would give me 3. Oh, okay. And then complete the graph of f of x on the axes below. Okay, so 2 would give me 4. 3 would give me 6. Okay, but then that carries over into the other function. So it looks like 4 gives me 5. And then we have 5 gives me 4. And we finish up 6 gives me 3, which is already there. There you go. Well, actually, I think we'll just go ahead and stop there because it doesn't say that it continues. Well, actually, no, the domain is everything greater than or equal to 3, so yes, it would continue. There you go. Okay. And there you go. It looks like the intersection of 2 lines that we've restricted to specific domains. Okay. Anybody have problems with that one? Pretty straightforward? Okay. That was pretty easy. Okay, let's take a look at number 4. Dealing with an exponential. The number of bacteria Y present at any time is given by the formula Y equals 15,000 times E to the negative 0.25 T, where T is the time in seconds and E is equal to 2.72, correct to 3 sig figs. Do you remember, what do we call E? What kind of number is it? Starts with an N? The natural number. There we go. Used a lot in logarithms and exponentials. It's a growth base. So A, calculate the values of A, B, and C to the nearest 100 in the table below. Okay, so if I were to go ahead and plug in 0, okay, so I'm looking for the value of A, Y is equal to 15,000, E to the negative 0.25 times 0. Well, what's anything to the 0 power? It's 1, so I'm going to end up getting 15,000. Okay. And see, this does say go ahead and round it to the nearest 100, but here's the 100 spot, but that 0 isn't going to be enough to do anything to it. We just have to stick with the 15,000. Is everybody okay with that? Yes. Okay. And then we'll go ahead and do the same thing for the other ones. In order to find B, try this one more time. There we go. We're going to go ahead and plug in 4. So let me go ahead and go to the calculator on this one. Now, it does say E is 2.72. So I'm going to go ahead and plug that in. Let me get out of this. Home, let's go to calculate. So 15,000, parentheses 2.72 to the power of parentheses negative 0.25 times 4. Okay. So what should I get when I push enter? Okay. So I'm getting 5,514. So to the nearest 100, would this be 5,500 or 5,600? 5,500. There we go. So I go ahead and say 5,500. Again, is everybody okay how I rounded that? Well, you're rounding it to the nearest 100, and this is the place that we're looking at. So we are interested in the 1, but only to let me know if I'm going to round up or down. Okay. All right. And then looks like our last one here, what are we doing? We want to plug in 8. So instead of retyping the whole thing, I'm just going to highlight this. Okay. I'm going to go ahead, if it'll let me, remove that 4. I'm going to plug in the 8. And what should I get when I do so? Okay. So 2027. So to the nearest 100, 2,000, 2,100. 2,000. There we go. 2,000. Okay. And then it says, on graph paper, using 1 centimeter for each second on the horizontal axis and 1 centimeter for each 1,000 on the vertical axis, draw and label the graph representing this information. Okay, I went ahead and did so ahead of time just so, we could keep moving. But using all these ordered pairs with what I got, this is the graph I came up with. Okay, I just counted every 5 by 1, and then going up every 5 was 1,000. So it fit just perfectly. 15,000. Okay. All right. So I'll give you a second if you want to go ahead and sketch that. And then now we just want to go ahead and answer the questions that are posed to us. Let's see, which were... Okay, using your graph, answer the following questions. After how many seconds will there be 5,000 bacteria? Okay, so 5,000 bacteria. We'll start here at 5,000. I'm going to go straight across. I'm going to go straight down. So the way I've labeled my axes, I would probably say 4 point what? Looks to me like I got 4.4. Okay. Remember, you have 5 units there between 4 and 5, so I'd say about 4.4. Was anybody getting anything else? 4.5? I think that's perfect. Okay. So I'd say 4.4. Okay. Then it says to the nearest tenth of a second. Okay, we did that. How many bacteria will there be after 6.8 seconds? Give your answer correct to the nearest 100 bacteria. Okay, so 6.8 seconds. So I'm going to do the same thing. Let's get a different color here. So 2, 4, 6, 8. Okay. All right, so what would you say for this one? 2,000 what? Now it says to the nearest hundreds. So 2,000... Okay, 2,900, okay. 2,800, I would say somewhere right about there. Perfect. Now, what would you like me to put? 2,800 or 2,900? What do you feel is more accurate? Caitlin, what do you think?
Whatever you feel best.
Well, I'm interested in what you want.
28.
2,800, there we go. 2,800 bacteria. There we go. Okay, and then C3, will there be a time when there are no bacteria left? Explain your answer. So what do you think, yes or no? What would you guys think here? I was looking at it from a mathematical standpoint. Mathematically, I would have to say no. Because even though this is a growth base, why is it a decay function? There you go. It's got that negative power. So if you think about your transformations, remember, if you're dealing with an exponential, if you make the power negative, it's going to reflect it with respect to the y-axis. Okay, that's why the growth becomes... Now, if the function is negative, then it reflects it with the x-axis. Okay. So what I'm thinking here, the fact that e to the x will never equal 0, that's why I kind of went ahead and said no to that. Okay. I mean, honestly, in real life, would you ever be able to virtually get rid of all the bacteria that we're talking about? I mean, if you just think about the products that they sell, like even hand sanitizer, they always say what? Kills 99.9%. Okay, so they're saying it's going to kill a lot of them, but we can't guarantee it will kill all of them. Does that make sense? Okay. Would anybody have said something different? Or maybe given a different reason? Okay. I believe we are now on our last problem. And then we will be able to start review 4. Okay. So let's see here. In the diagram below, PQRS is the square base of a solid right pyramid with vertex V. The sides of the square are 8 centimeters. Okay. And the height VG is 12. Okay, so we'll go ahead and put that 12 in there, 12 centimeters. M is the midpoint of QR. All right. So write down the length of GM. Okay. So if I were to go GM right here, well, that has to be what? Has to be 4. Okay. Because M is the midpoint over there, so if I created another midpoint over here between S and R, that would also be 4. That'd be 4. I mean, you'd be dealing with a square. Okay. So that one's pretty straightforward. Now it says calculate the length of VM. So it wants this guy right here. Okay. So basically we're talking about the slant height for that particular face. Okay. So ideas. There you go. We can just go ahead and use what? Pythagorean theorem. In fact, let me go ahead and sketch this over here. Remember, we've got G in the middle, okay, the midpoint of the base. We got V up here. We got M over here. We just found GM to be 4. We're given the height is 12. And does anybody want me to go ahead and run through the motions, or is it okay if I just go ahead and put 12.6? Okay with that? Okay. So 12.6. That is exactly what I got. Okay. Paste this here. All right. Well, now it says find the total surface area of the pyramid and the angle between the face VQR and the base of the pyramid. Okay. So the total surface area of the pyramid. Okay. What I did was I just went ahead and found the area of the base, the area of one face, and then multiplied it by what? 4. That's all I did. Did anybody happen to do anything different? Okay. What's the area of the base? Okay. So the area of the base is 64. We're talking square centimeters. Okay. And then for a face, bless you. Okay. We're going to take half the base times the height. Okay. Well, we just found that the height, okay, that slant height we just found to be 12.6. So really, this represents one of the 4 faces. I got this to be 12.6. We know that the base edge, like for example, RQ is 8. So I'm wanting to find, okay, 1/2 12.6 times 8. Okay. All right. So let's see here. Let me get rid of all of this. Oops, it's not letting me do that. Let's go here. Document B. Okay, so 0.5 times 12.6 times 8. Okay. That's the area of one face, but there are 4 of them. Okay. And then I want to add the area of the base itself. Okay, so I'm ending up with 265.6. Okay, do we agree? Okay. 265.6 square centimeters. Okay. And then it says the angle between the face VQR, well, this is the face on the right side of my diagram here, and the base of the pyramid. Well, see, this one's really nice because they're actually wanting me to find this angle VMG. Okay. And there's actually a variety of ways we could do it. What were the trig functions that we talked about? Sine, cosine, and tangent. We have all 3 of the sides, so really whatever you want to use. What do you like, Eli?
Why don't we use tangent?
Okay. Those are nice numbers? Okay, perfect. So from theta's perspective, 12 is the opposite, 4 is the adjacent, and of course that would be the hypotenuse. So I'm going to go ahead and say tangent of theta is equal to opposite over adjacent. So that would just be 3. So what do I do if I want to find the angle measure? Take the inverse. There we go. So tangent inverse of 3 should give me theta. And let's see what that comes out to be. So trig, I'm going to choose tangent inverse right here, 3. So I'm getting about 71.6 degrees. Is that what you guys are getting? Okay. Did anybody use another trig function? You should be getting the same measure. Should be maybe slightly off because we rounded. Okay. What was it again? It was 71.6. 71.6 degrees. There we go. Perfect, perfect. And that bell is about to ring. Okay. So tomorrow we'll come in. We will go ahead and start with review 4. In fact, I believe there's only, 3 questions on there? So we should be able to wrap that up tomorrow, hopefully even start review 5, and then we will go from there. Okay, nice.